I added in this statistics and probability unit really to help you. There's a lot more statistics and probability on the SAT and the ACT than there has been previously. And this is something that we mainly, don't talk about a whole lot, so I put this unit in for you. I know that we have some juniors in here, and juniors typically think about starting to take their ACT and SAT in the spring. So I wanted to get this unit fitted in before the spring, so at least you would have some experience with the kinds of concepts that you're going to be faced with on those tests. Okay, so basically the unit is part statistics, about half probability, a little bit of both. Today we're just going to review some overall information about statistics, and we're going to do some specific ways to represent data. So statistics in general is it's a branch of mathematics that studies techniques for collecting, organizing, and interpreting information. The data consists from several locations: observations, responses, counts, or measurements. So let's talk about some specifics. Statistics really can kind of be branched into two different types of statistics. We have descriptive and we have inferential. This unit is just going to be based on descriptive statistics, how we organize, summarize, display data. That's what the stats in this unit is going to be about. There are other kinds of statistics where we draw conclusions about a population using a sample, a bit more intense, I think. There really isn't much inferential statistics at all on the ACT and SAT, so I didn't focus on that. I decided to focus on just descriptive statistics. But there are some, there are two different kinds that we can look at. The different study types, we can have an experimental study type or observational. Let's talk about the differences. And the reason that we're talking about this is sometimes you'll get a question about a study. And they're going to ask, just a question like what, well, I have a few on the daily work that you can look at. But let's look at the differences. So an experimental study is where a scientist or a person who is doing this would take measurements, they would manipulate the system, take more measurements. So for example, if let's say a pharmaceutical company was doing some kind of a study on Tylenol, some kind of new Tylenol or something, and they wanted to have a control group, some people that really got the pill, but the Tylenol pill, but didn't really get it, and then we'd have the other group that was the actual group that they were doing the experiment with. That would be an example of an experiment where they manipulate things. They would, that's one example of an experiment where things would be manipulated for purpose of discovering whatever it is that they want to discover. Which does this type of Tylenol work better than, or maybe they'd give two different types of Tylenol. Which one works better? Those kinds of things. So that would be an experimental study. Typically, experimental studies have control groups. Not always, but typically they do, like a group that will do something different or nothing. Then we have observational studies where there's no manipulation. They don't mess with the population. They just watch. They just observe. They just observe by, taking samples perhaps. Maybe they're doing soil samples. They want to see, I don't know, how a particular location, how that soil changes over time. I mean, who knows? It could be anything. It could be birds. I mean, anything. They could really do measurements or observations on something. And they don't mess with the variables. They don't have a control group. There's nothing that they change. So that's the two basic study types. The data, to do a population, that would be all of something. That would be kind of hard. If you think of all of anything, all cardinals, how are you going to find all cardinals? I mean, so really that's kind of rare to do a study on all population, unless maybe it's statistics about the census, where it includes everybody. That could be something where we would use all the population. But usually it's a subset or sample of the population is what they would use as their data while they are looking at whatever statistical study they're doing. There are two types of data. We have quantitative data and qualitative data. Quantitative data is numbers. Things that, like if you're taking measurements, soil measurements, those would be actual numbers, right? It's not how you feel about something, it's a number. Qualitative would be more like, let's say I wanted to give you a survey and ask you what you thought about technology, for example. Something that's kind of near and dear to our hearts right now. So maybe I'm giving you a survey and you're going to give me like your thoughts. That's not quantitative data. That would be qualitative data, right? That would be something that would be an attribute. What do you think? They're not numeric values. It's more like a label or a survey. Does that make sense about the two differences? Okay, so two different kinds of data. Then there's lots of different kinds of sampling methods. This is just a general, the most general ones. There's we're collecting data. We found our sample that we want to collect data from. We know which kind of data we're going to collect, qualitative or quantitative, maybe both. Some studies collect both kinds of data. And then how are we going to sample? What are we going to do to sample? So one is the random sample is actually it's random. Every member of the population has an equal chance of being selected. So maybe they do a random number generator or something. I mean, they would find a way to make it random. There's also stratified random, where a researcher would divide the population that he's going to research into different groups. And then he would select at random from the group. Maybe he would separate it into, I don't know, regions of the United States, some people from Texas and some people from, New Mexico. Maybe he'd want a certain number from Texas or a certain number from New Mexico. That would be a way to do a stratified random, where you would take the population and break it into groups and then randomly choose from in those groups. We have systematic. That's where a researcher would use a rule, like they're going to use in their sample every fourth. Maybe they'll put people in alpha order and pick every fourth one, something like that. So there's a kind of a rule that they would use to select the people that they want to, or objects that they want to have in their data. There's a convenience sampling, and that's where a researcher basically just uses the population that's easily accessible, the easiest ones to use. That's convenience. It's a convenience sample. They actually have a thing like that. And then last is self-selected. That's where you get people to volunteer for a study. Maybe you've heard, advertisements about, oh, we're doing a sleep study. Would you volunteer? If you want to volunteer, they would tell you whatever. Maybe you get money or something, or free services. So they actually are. So we have self-selected sampling methods as well. Okay, so that's just a general overview. We're going to focus on some specific ways to model or represent data. So let's go to the next slide. So we're going to look at three different kinds, actually, I guess technically four. We have line plots, stem and leaf plots, and histograms and frequency distributions. Those are what we're going to be working on today. So you may already be familiar with all of these things, certainly possible. So this will be an easy lesson for you. And really this lesson has to do with being accurate and labeling things appropriately and having an even, scale. That's what this lesson has to do with. And do you know how to do a line plot, a stem and leaf plot, etc. So let's kind of walk through them one by one. Let's work with line plots first. Line plots use a portion of a real number line to order numbers. This type of organization is useful for ordering small sets of numbers, like less than 50 numbers. This number line is not necessarily going to be given to you with numbers on it. You're going to have to decide. You don't have to start at 1. If you don't, let's say your data starts at 150, you're not going to want to start your number line at 1, right? That wouldn't make any sense. You'd start your number line at 150. So you start your number line where you believe it models the data the best. It's your choice. Typically, you do need a spot for each piece of data. So like skipping, and the scale needs to be even, so that if, sometimes like I will do sometimes, I'll just label 2, 4, 6, 8, and I'll leave the odd ones not labeled. Well, it has to be an even scale so that people know how to read your scale. So we need to be sure that it's even. So let's also, we need it to be labeled. What is this? What are you modeling? And they're typically going to tell you what it is, so you would just write down what it was. So let's start. So what we do is we take each number and we enter it as like a point. So 13, I'm going to go over here above 13 and I'm going to put a point. And I'm going to cross it off so that I know that I've done it. That just helps me. Do you have to? No, it's totally up to you. I would go to 14 and I would put a point. Okay, I've done 14. Then I would go to 8 and put a point. Then 10 and put a point. Then 11. And then back to 13. So when we have more than one piece of data, what we do is we stack the points. We stack them on top of each other. So 13, I'm going to start a stack right there of 2. Then I have 15. Got that one done. Then I have 8. Okay, I'm going to have to stack that one. Then 9. Then 4. Then 14. 11, 14 again, and then 6. Now when we are creating these line plots or stem and leaf plots or histograms, frequency distributions, this is the rare time when I am okay with you using like a colored pen or something. Maybe you want maybe you want your dots to be different colors, or maybe you want them to be all the same colors. It's totally up to you. Give you a little bit of freedom with that. Again, with the histogram, we're going to be drawing bars. You can color those in, if you want them in different color, however you would like to do that. I'll let you have that freedom to do that. All right, so are we okay with the line plots? Everybody good with that? Okay. Alright, so we can look at a line plot and it'll tell us some information. The kinds of things that they'll ask you is which score occurred most frequently. And we should be able to look at that and just say, well, we can see right now, right, it was 14 occurred most frequently. It's a 15-point quiz, thankfully. Okay, this is not a 100-point quiz. It's a 15-point quiz, and 14 occurred most frequently. They could ask you what were the range of the scores. Do we remember what range is? Right? Just the difference between the biggest and the smallest. The range of the scores. We would be able to tell that by the line plot. Okay? Alright, so let's go to stem and leaf plots. And again, you may have done this before. So the leaves represent the units digit, and the stems represent the tens digit. We can also use them to compare two sets of data. I have an example of two sets of data. And actually, let's just talk about the two sets of data so I don't forget, like I did last period. Okay, so we have the stem right here. That's our, as it said, the stem is the tens digit. Okay. The leaves, notice how the leaves are written in numerical order. You can't jumble them up. They have to be in order. See how we have like a triple leaf, 5, 5, 5. That means that 15 occurred 3 times. Right? And we can do a double. That's useful to compare two sets of data. Notice how the stem is in the middle, and I do have one of these on your daily work for you to practice, one of these double ones. The stem is in the middle, and then this leaf is regular, but this one is kind of like a reflection. Right closest to the stem is the smallest number, 0, and then it goes out. So as you go out from the center, you get larger depending on which way you would go. Okay, so notice also how they have a key down here. You're going to need to put a key with yours as well. What number do you pick? Whatever number you want. They chose to pick a 61. Why? I mean, I don't know. It's down here, 61. They just picked 61. You can pick whatever number you want. And then you say, what does that equal? What does 6/1 mean? It means 61 hours, because that's what this data was about hours. Okay? So that key, you choose whichever number you would like. Okay, so let's build a stem and leaf plot. We're actually going to use the data from number 1. So I'm going to kind of unhighlight that so I can use that data again. And we're going to create the stem and leaf plot. So let's focus on the stems first. That's the tens digit. I have a 1 and a 0. It looks like that's all I have are 1s and 0s. So I'm going to have a 1 and a 0 here. Those are my stems. And we would just list however many stems that we had. Alright, I'm going to start on 0. You can certainly start wherever you like. Since they have to be in numeric order, you probably should pay attention to that as you're writing them down so that you don't have to erase and change the order. So I'm going to look for the smallest number that I can find through this data. It looks like 4 is the smallest number, so I'm going to put a 4 here and cross that one off. And then I look for the next smallest one. It looks like 6. And notice we're not putting commas between them. They're just a list. It's just a list of numbers. So we have a 6. And then which one is the next smallest? 8. So we have an 8. It looks like we have more than one 8. So we list them, as many as we have. We have to list them all. And then we have a 9. Okay, it looks like those are all of our single digits. Now let's go to the tens digit. Looks like we have a 10 here, so that will be 10. And then we have an 11. Let's see, do we have more than one? We do. We have another 11. Looks like that's all the 11s. Let's see, the next one would be a 13. And we have another 13. And then we have some 14s. So we have 1, we have another 14, and then another 14, and then lastly a 15. Okay, so we've used all that data. So we have the plot done. We need to do the key. Just pick a number. I just picked 1/3, and so that means it means 13 points, right? Isn't that what we were looking? We were looking at scores for a 15-point quiz. So 1/3 means 13 points. Okay. So how are we on stem and leaf plots? We okay? All right. So let's talk about histograms and frequency distribution. So these are useful for representing numbers grouped into intervals. And a histogram is very similar to a bar graph, but they are different. Okay? A histogram bars are always vertical with no spaces. There are no spaces, which brings a little bit of a challenge to us. I'll talk about that in a minute. There are no spaces between bars, and the labels are always number. It's always numeric. That's a histogram. If it doesn't meet that criteria, it would be a bar graph. All right, so that's a histogram. We're going to be working with histograms. This is a frequency distribution. So you'll be given a set of data, and now I have not, just for time's sake, I went ahead and wrote this up here. You're going to have a frequency distribution to do on your own, and I want you to take note of how it's set up. Notice how there's an interval that you decide. You get to decide what your interval is going to be. Notice how the intervals start and stop with the same number, which is very disturbing to students. Okay, we have an interval from 20 to 30 and 30 to 40. Where is 30 going to go? I mean, that's the troubling thing. These histogram bars have to touch. They have to touch. So we can't go from 20 to 29 and then 30 to 39 because they wouldn't touch if we did, right? We need them to touch because that's what a histogram is. So we decide where the 30 is going to go, and we're consistent. So I have a group of data, and I have, all these numbers, and I have 30 in my data. Where am I going to put the 30? Are we understanding what I'm saying? Where am I going to put the 30? Am I going to put it here? Am I going to put a tally mark for it here? Or am I going to put a tally mark for it here? I would suggest that you just use the first one all the time. The first time you see the 30, use that as your tally mark. Okay, that's my suggestion. You need to be consistent whatever it is that you're going to do. Okay, so if I have a 30, I'm going to put it in the first place I see a 30. So you're going to get to decide how to do the intervals. Do you have to do intervals of 10? No, it depends on the data. Maybe you want to do an interval of 12. I mean, it just kind of depends on what the data looks like as to what you want to do. All right, so what they did intervals of 10, and they tallied their data, and then they counted up how many tallies they made, and that was the frequency. Okay, so that's you'll have to do a frequency chart like that. We use a frequency chart. It's best to do a frequency chart in order to do a histogram, because they build off of each other, right? Because histograms order the data in intervals, and so does this frequency chart. Okay, so let's look at setting this up. This basically is the common thing that you would do if you're not going to start this at 0. If you're not going to start your scale at 0, you need to put one of these in. You're going to be drawing them yourself, right? There's not going to be one given to you. So if your data doesn't start until 150, you don't want to start at 0 on your scale, right? That doesn't make any sense. So we would put this little break in there at the beginning if we're not going to start at 0. Okay. So here we're starting at 20. We're not starting at 0, so I have the little break there. And I'm going to start this at 20 right here. That's where 20 is going to start, at this beginning, right after the break. And I need to go to 80. So we just need the scale to be as even as possible. You know, it doesn't have to be perfect. Some students like to use a ruler when they're doing this. You don't have to. It's totally up to you how you want to do this. So we're going to go from 20 to 80. And sometimes it's helpful if the data works is to write the beginning and end, and then go to the middle, and then kind of just make it try to make it as even as possible, because how you set these is how wide the bars are going to be, right? And we want the bars, really we want them to be the exact same size. I mean, we're doing this by hand, so they're not going to be the exact same size, but you know, we don't want them to be really off. So you can label some of them or all of them, but they have to have at least a label so that somebody could pick out what the scale was. If you're going to leave some of these blank, well, first of all, it has to be an even scale. I mean, we've learned that from a long time, right? When we first started making graphs, it needs to be even. So I'm just going to go ahead and put the numbers in. And I'm going to label this. We have to label. That's part of what you're doing. I don't think this lesson is difficult unless you're not very accurate. You know, if you're just going to forget to do things, then they're just, you know, you're not going to have a complete picture. So this is class ours, and you know, who even knows what that means? We're just writing down what they wrote. I don't remember what the situation with this was. So this is class ours. Now our frequency goes from 2 to 10. So here this scale needs to go from at least 2 to 10. So I'm going to start at 2. I'm just going to go by 2s. So 2, 4, 6, 8, 10. And this label is going to be the number of students. Typically this label is written vertically. Do you have to write it vertically? No. But usually it would be written as number of students. Okay, so now we have our histogram ready to draw. Okay, so let's go to the 20 to 30 branch. That's 5 students. So I'm going to come up here to 5 and then draw that. Okay. Then the 30 to 40 is 8 students. So we're going to go up to 8. Remember, the bars are supposed to touch. Then 40 to 50 students is 9. So I'm going to go up to 9. Let's see, what do we have? 50 to 60 students is 10. So that's all the way up to 10. 60 to 70 students is 6. So that's back down here. And 70 to 80 students is 2. So that's here. And if you wanted to do a pattern on the bars or colored in, it was totally up to you. That would be our histogram. Everything's labeled, the scales are even. How are we with that? We okay? Okay.